I'm Kasey, an educator that uses biointeractive's Model Builder tool to help students make sense of biological phenomena in my higher ed classrooms ranging from large enrollment introductory courses up through senior level seminars and labs. In this video, we'll learn how to use stock and flow models. These are models that are designed to show material transfer through systems. Stock and flow models are often used to represent biosynthetic pathways that use up reagents, the cycling of materials or energy, or the transport of molecules. On the Model Builder tool page, we can sort the model types to see all of the available stock and flow models. We'll use the carbon cycle as an example, since this is a process in which we can track the flow of a specific material, namely carbon. I will open that model now. The key difference with stock and flow models as compared to the other model types in Model Builder is that in a stock and flow model, each object has one of three defined types: a stock, a variable, or a flow. Stocks represent sinks or sources of materials that can be measured or counted. Flows are movements of these materials in some form. And finally, variables are factors that influence other objects but are not stocks or flows themselves. The key to making a stock and flow model work is that the materials in the stocks are consistent. So a stock of carbon can only flow to another stock of carbon, not to, say, a stock of energy like ATP or to a process. As always, there will be helpful information in the instructions that will help you figure out the parameters of your model and which objects are each type. For now, I'm going to minimize this so it is out of our way. As with any other model in Model Builder, we'll begin by dragging our objects out into the workspace. However, before we start to connect them, we're going to need to assign object types. To do this, we'll click on the object and then we click on the type. We'll start by finding the stocks of carbon. Here, carbon in the atmosphere and carbon in the biosphere. Next, we'll find the flow processes that move or convert carbon between these stocks. In this case, photosynthesis and respiration. Notice that this turns the flow into an arrow with a valve on it. And there's two ends. These ends can be left as is to show infinite input or output, or they can be connected to stocks within our system. We'll get to how to do that in a moment, but first I want to finish assigning my object types. We still have sunlight left, which is neither a stock of carbon nor a process through which carbon flows. However, we do know that sunlight can affect the flow of photosynthesis, so we'll set it as a variable, and we'll use a positive connector to show that it promotes that process. To connect two stocks using a flow, there is a specific order of steps that you need to take. And I know this can feel a little bit overwhelming when you first experiment with it, but I find that it does get a lot more natural with practice. So we'll start by clicking on a flow, in this case, respiration, and then we will click the Flow From button. We'll then click the stock that is the source of the flow. In this case, the source of carbon for respiration flow is carbon in the biosphere. Next, we're going to want to connect respiration to its destination. So now we will click the Flow To button, and then we'll click the stock that is the destination. In this case, the destination of carbon that is flowing through respiration is the atmosphere, because carbon dioxide is exhaled during respiration. You can also make these connections by clicking on the infinity symbols that represent the source and destination of the flow, like so. If I need to fix any incorrect connections, I can just click these unlink flow buttons. Once my students have built their stock and flow models, my favorite way to use them for sense making is to ask prediction questions. For example, if we were dealing with a closed system that has low access to sunlight, would we expect to have more carbon buildup in the atmosphere or in the biosphere? Stock and flow models can require a bit of a steeper learning curve for students, so I have found that it's best to start them off in Model Builder with a conceptual or causal model so they can get the hang of the tool before diving into stock and flow. You can also give them a head start on these models by pre-assigning the object types yourself and providing students with a partially built model file. And you can learn how to do this in our Creating Differentiated Models explainer video. Using stock and flow models like this has really helped my students grasp complex biological problems like membrane transport or the flow of electrons in cellular respiration. And I hope that you'll enjoy using them in your classes too. Happy modeling!